Hello, welcome to the first of our video tutorials on datasheets. I'm Kate, Applications Engineer at HEPCO. Today we'll be looking at the GV3, HDS2 and SL2 datasheet. The datasheet is designed to cover the core elements of an application and is key to specifying the products best suited to that application. The datasheet covers a variety of aspects from load to duty cycle and environment of use. We'll be taking a closer look at these using an example application to complete the datasheet. Let's take a quick look at the application we're going to use to complete the datasheet. Here is a small section of a production line in a factory making cakes. Cakes pass along a conveyor and are sorted into rows before they go on to be packed. A paddle is used to push the cakes into position on the conveyor. Guidance is required to move the paddle back and forth. This brief description of the process is exactly what is needed to complete the datasheet. In this box, you should provide a short description of the application. This is a food industry application, with a conveyor arranging cakes for a packaging process. Paddles are used to move the cakes into position, and guidance is required for this movement. With this datasheet, there is the option to provide information for 3 axes of movement. In this application, there is only one axis of movement, so only the x-axis column needs to be completed. In some cases, you might also have vertical and horizontal movement. Information can then be given in the y and z-axis columns. Next, the datasheet asks for information on the loads the system might see. In its simplest form, this would be the weight of the object you are moving. In some applications, there are additional loads to take into account. As an example, you might see tension forces from a material in a winding application. You might also see resistance to movement from a secondary component such as rollers. In this application, we must consider the mass of the paddle, but also the force applied when the paddle makes contact with a cake. This resistive force is somewhat unusual, but it is something we need to take into account in our specification. The weight of each paddle is 0.5 kilos, and there is also a 5 Newton resistive force from the paddle. Next, you need to state the orientation of the system. In this application, the slide is mounted horizontally with the V's at 9 and 3 o'clock. On the datasheet, this can be communicated by writing horizontally mounted with the V's on a horizontal plane. The next section of the datasheet breaks down the load into its component forms, direct loads and moment loads. First, you need to indicate the direction of the load relative to the slides and bearings. In this example, the weight of each paddle acts downwards, so there is an L1 load. If the slide was mounted with the V's at 12 and 6 o'clock, there would be an L2 load. On the datasheet, the direction of the load is therefore L1. The next 3 items on the datasheet look at the different moment loads that might act on our products. In these instances, you need to indicate where the centre of mass of the load is in relation to the slide and where any other forces are acting. In our conveyor application, the centre of mass of the paddle is 108 mm from the centre of the carriage. This offset applies an ms moment on the carriage, so the ms offset is 108 mm. We must also consider the force applied as the cake and paddle make contact. The force applied is a result of the coefficient of friction and the weight of the cake. This is 5 newtons, and it occurs at a distance of 120 mm from the centre of the carriage, but also 80 mm below the carriage. Where the resistance to movement acts below the carriage, it applies an M moment to the carriage. The M offset is therefore 80 mm. Where the resistance to movement acts at 120 mm to the side of the carriage, it applies an MV moment. The MV offset is 120 mm. The next section of the datasheet relates to the linear accuracy and repeatability required. Accuracy and repeatability can be illustrated using the example of an archer firing arrows at a target. The accuracy of the archer relates to how close to the centre of the target the arrows land. The archer wants each arrow to lie within the yellow circle to be accurate. The repeatability relates to being able to hit the same spot again and again. Whilst the arrows are not in the yellow circle, and therefore not accurate, all of the arrows land in a small area of the target, so there is a good level of repeatability. In a majority of applications, the user will be most interested in repeatability. This means that every time a carriage moves to a defined point, its final position is within the defined range. In this application, the customer needs the movement to be repeatable to ensure the cakes are in the correct position. Every time a paddle moves a cake, it needs to be in the same position so that it is correctly lined up for packaging. Each cake is 50 mm wide, and the channel they fit into in the next process is 60 mm wide. The customer needs the centre of each cake to be within 5 mm of the centre line of the channel, so that they don't clash with the channel as they go through. These cakes won't make it through, as they are outside the line of the channel. The repeatability required is therefore plus or minus 5 mm. Following this, the datasheet requests information on the stroke, which is essentially the distance through which the carriage travels. In this application, each of the carriages needs to travel back and forth through 200 mm. The stroke required is therefore 200 mm. If you know the customer's speed, acceleration and deceleration rate, you can enter these into these rows. If the customer does not know the linear speed, acceleration or deceleration, it is simplest to state how long it should take the carriage to travel through the stroke. In this case, the customer has not defined the speed, acceleration or deceleration, but they have stated that they wish the carriage to travel through 200 mm in 2 seconds. As we do not currently know the acceleration and deceleration rates, we will leave these sections blank. The next row of the datasheet relates to how busy the system is. In some systems, the motion is a simple movement forwards and backwards. In others, the carriage moves to one point, then on to another and another, with a single movement to return to the start. In this application, the carriages move back and forth through the full stroke and do not stop mid-stroke. 12 cakes per minute pass by each of the paddles for 8 hours every day, 6 days a week and 50 weeks a year. This is exactly what we want you to tell us on the datasheet so that we can calculate the distance travelled each year. This information can then be added to the datasheet. Next, the datasheet asks for the required life of the system. Life is very much dependent on application and is always driven by the customer. The life of a system can be considered to be the point at which a major overhaul of components is required, be it the replacement of bearings and slides, or the adjustment of components that are worn. In this case, the customer has requested a life of 2 years. Following on from life, the datasheet requests information on lubrication. Whether or not lubrication can be applied depends very much on the application. We would always advise lubricating slides and bearings. This significantly improves wear resistance, reduces noise, and improves load capacity. In some cases, it is not possible to apply lubrication. This may, for example, be where the slide is working over foodstuffs or electronics components, and the customer cannot afford for drops of lubricant to fall onto the product. When a product is not lubricated, we modify our load and life calculation, so it is very important that we know what the customer intends to do. In this case, there is food passing under the slides and carriages, so the customer cannot use a traditional grease to lubricate the slide. They have, however, indicated they could use a food-grade dry film lubricant. This has the same effect as a traditional grease, but will not drip down off the slides, so is ideal for this application. This can then be communicated on the datasheet. Something else that it is important to communicate is where the product will be used. Some applications use wash-down cleaning processes, are in a clean room environment, working outdoors, or in a marine environment. This information helps to determine the most suitable product and materials for the application. In this case, the system is working in a food production environment. It will not be exposed to washdown or harsh cleaning chemicals. A few short points to cover the application details should suffice here. Something else which can affect material and product selection is temperature and humidity. We'd like to know the range of temperatures the unit might see and any possible exposure to humidity in the air. If the air is humid or there is exposure to water, there is potential for steel to rust. In high temperature applications, polymer-based components may deform. In low temperature applications, grease can become more viscous, making it harder to move components. In these cases, there is the need to be careful with material and component selection. If these details are specified initially, provisions can be made to specify suitable materials for the application. In this application, the operating temperatures are ambient and dry. For the method of driving, we'd like you to indicate how the product will be moved. Would it be by hand or using a motor? And then how might the product be connected to the motor? For example, with a screw or belt drive, or perhaps a rack and pinion. There are a variety of drive methods available, and the application usually determines which is most suitable. Typically, we use rack and screw drives in vertical applications, but belt drives, electric actuators, and friction drives are also possible. In this application, the customer is using an AC geared motor to drive the carriages back and forth. Each of the carriages is mechanically linked by a rod, which then joins to the motor. A summary of this information can be given on the datasheet. The next row of the datasheet asks you to make an initial selection of the product you think most suitable for the application. What you need to indicate here is the item or range of products you think are most suitable for the application. In the cake manufacturing process, stainless steel is a requirement, as it is a food-based application. The movement requires slides and carriages only, so SL2 is the most likely choice. On the datasheet, you can state which product range you think is required. The final section of the datasheet allows you to add comments on the application and provide a drawing or sketch. Customers aren't always able to provide a full manufacturing drawing at the beginning of projects, as there are so many details yet to be defined. In most situations, a simple sketch or diagram to illustrate the application is sufficient. You can provide this at the end of the datasheet or in an attachment when you send your inquiry to us by email. Here is a simple illustration of the application, showing a couple of views of the layout and giving key dimensions and information. As you can see, it's possible to clearly and concisely convey the idea with a simple image. On the datasheet, you can add any comments you think might supplement this information. So there we have it. We've completed the datasheet and have provided initial information on the application. The completed datasheet is a firm basis on which to assess the application and suggest suitable products. Once our technical team has received the completed datasheet, they can run through the details to check what is most appropriate and make suggestions for the customer's consideration.